Okay, welcome back to CAD That Works, and today we're going to be doing something a little different, but more or less the same. I'm going to be reverse engineering a broken Megalodon monster truck. This is a toy monster truck, and it is my son's favorite, and as little boys do, they like to throw things around, and as such, he broke the wheel off. So, first thing I'm going to do, I'm going to need to take this hub out of this wheel, which is going to be slightly difficult because this is not rubber, this is hard plastic. But I think I can get it out with my vise. So I'm going to take that out to the garage and try to pop that out. And when we come back, we'll take some measurements, get it onto Onshape, model a replacement, and 3D print it and test it. Okay, welcome back. So I got the hub out, and it was not easy because it has these little flanges on there to keep it in the wheel. Honestly, I'm not sure how they even got it in that tire. Maybe it was formed in place, or maybe they heated it up and have some kind of spreader mechanism, but this is very rigid plastic. But anyway, we got it out. So the next step is going to be taking some measurements with my calipers here. I won't bore you with that. I'll do that off screen, and then we'll come back and pop that in Onshape and model up a replacement. I do need to get the part off the axle. As you can see, that's pretty thin interface between the hub and the axle connector, so I'll probably have to redesign that so it will actually survive my son, considering it's going to be a 3D print versus this molded ABS they have here. But yeah, I'll detail all that in Onshape, so stay tuned. Okay, so we've taken all the measurements of the hub from the little monster truck. Let's go ahead and jump right into Onshape and get this prototype started. So create, document, let's call it wheel fix V1. Get into our workspace, front plane, let's hit sketch, select that front plane right up there. And we're going to do a revolve, so let's go ahead and select our line and our construction. First, we're going to create our axis of revolution because we're going to be using the revolve command. I hit L again to get out of there. Just do that. And actually, the first thing I'm going to do is change those workspace units. I'm going to do it in millimeters because that's what my caliper was in. And yeah, so that's just going to be easiest for right now. Okay, so let's go back to sketch. Okay, so let's go ahead and draw our basic outline of our hub here. Use our line command. Just going to draw this out. We'll worry about dimensions once we're done. Okay, so let's go ahead and add those dimensions in there. So to do the actual diameter, so the radius, we're going to drag that dimension over there. And we'll just kind of define all those for right now. Okay, so that smallest diameter, 8.94. Second smallest, 13.67. Next one is going to be 15.41. And the OD of that hub is 18. Now the overall height, let's go ahead and define all those dimensions. First one is 1.89. Next one is 9.53, followed by 11.56. And the overall length is 18. Okay, so let's go ahead and actually we need to add one more feature, and this is the actual hub. Now we need to add a little flange because If you recall, that hub we took out had some internal flanges to that tire. I'm not going to do that again. I don't think those would survive being in search of the 3D printing. So we're just going to do a little flange on the back here. This would be the bottom of the hub. And let's trim that up. Okay, let's dimension that. Let's make that 23 millimeters. That should be adequate. But let's make it 0.5 millimeters thick. Actually, I want that to be there we go. Okay, there we go. Just having a little issues over dimensioning, over constraining myself there. So, okay, and let's go ahead and do our revolve. Revolve axis is going to be that construction line we did in the center. There we go. So now we need to create the actual axle part. So hit sketch, select that bottom surface, circle, snap to that center point, and that diameter was 5.5. Okay, we're going to go ahead and extrude that up. We're going to do that 6 millimeters. So now the problem here is I don't think if I 3D print this, that is going to be very strong. That will probably break pretty quick. So I'm going to beef that up. I'm going to make a little conical revolve around there. And actually, I might just try to do a chamfer. There we go. So worked out pretty good. Now we're going to add a little hole for the actual axle to go into. Now it's going to be smaller than the axle itself because we are going to heat that axle up and press it in there. And I'll probably end up using some epoxy too just to make sure it doesn't come off. But I'm going to select that face for my sketch. Let's go ahead and snap to the bottom view. Oh. You can see I did not center that cone, so we need to go back and fix that here in a second. I'll make that 1.9 millimeters. All right, let's just go ahead and we're going to fix that. We're coincident. Select the center. There we go. Much better. Okay, so let's go ahead and make that hole for the axle itself. So I selected the sketch I did of that little circle. Now we're going to do remove. And we're going to go down 6 millimeters. I'm going to add a very tiny chamfer there just to help with assembly. 0.5, let's even do 0.25 millimeters. I think that'll be good. Okay. So that's the basic hub. Now we're going to add some little features because the one he had some little lug nut looking features in there. So let's go ahead and do that. Select that surface there. Snap to our top plane. Circle command. Right about there. Let's make that 5. Now let's do, there we go. Okay. Not being too exact here, it's more just for looks, but try to get it as best we can. Extrude that sketch. Let's do 0.25 millimeters tall. Okay, so now we're going to do a circular pattern. Go up here to our pattern command, circular pattern. We're going to do a feature pattern. Select that extrude and that sketch. Our axis is just going to be that construction axis we did earlier. You see it was hidden there, so I just went up and I unhid that sketch number 1. So we're going to select that. Now, what's nice about Onshape is it kind of automatically spaces those. What we're going to do, let's see what 10 looks like. That looks perfect. Okay, and there was a few more on this bottom surface of that hub. Accidentally hit sketch again. Circle command. Let's make those 1. That's too much. That'd be perfect right there. Extrude. 0.25. And we're going to do the same thing, same circular pattern. Change it to feature pattern. Select our 2 features. Select that axis of pattern. Let's do 8. All right, that looks good to me. Okay, so I think this is ready for 3D printing. I'm probably going to do it from this bottom surface up. I will need some support material. But again, I don't really care what that surface finish is going to look like on the back side of that wheel. I really care about how it's going to look up here. So let's go ahead and export this. Right click on part down here, export. Let's call it wheel fix _1. Check their settings, everything looks fine. Export. Okay, then let's jump right into Prusa Slicer and get this thing 3D printed. Okay, so we're in Prusa Slicer. Hit Control I to go ahead and import that. Wheel fix, there it is. All right, comes in, scaled perfectly. I do want it oriented in this manner. I'm going to do custom supports again, because I do not really want supports in that hole there. So I'm just going to do it. Let's go ahead and rotate this. I get a better bottom view of that. I don't want to get it in that hole at all. Just kind of left click, drag it around. There we go. Okay. So now I'm going to change the infill. Since this is a functional part, I'm going to do 85%. I am going to use PETG. And I'm going to change my layer height to like 0.15. Okay, let's go ahead and change that back to 85. Let's go to our print settings. Let's make it have 3 perimeters. Make the wall thickness a little better. And I'm going to make my first layer height. I'll make that 0.25. Make it a little thicker. Makes it stick to the plate better sometimes. So let's go ahead and slice it, see what happens. All right, there we go. Looks pretty good. I think we're ready to go ahead and print this. Let's go ahead and export it. Looks like it's only going to take 42 minutes. So I'll pop that off, and when we come back, the thing should be 3D printed. Okay, welcome back. So the 3D print is complete. Came out pretty good. I went ahead and took the support material off. Finish on the back side. Looks okay, but again, doesn't really matter since it will be on the back side of the wheel itself. Just kind of comparing it to the other ones. I did skip a little bit of the detail inside there, but it looks good enough, I think. Doing a quick test fit on the tire. There we go. Perfect fit. Again, I did add a little flange back there to help keep it secured, and I'll add some super glue when I actually assemble these together, because it probably will be getting thrown again. And so the next step there is I'm going to heat up this axle, and I'm just going to press that on there. See, it's got some little ridges on there. Once it cools down, so just keep it there in place. And the depth of that hole there will maintain how far it gets pushed in. I'm not going to heat it up that much where it would push through. That'll kind of, keep it equivalent as far as spacing with the other wheels. So let's go ahead and get my lighter here. And I'm just going to hold that flame over there. I don't really have a set time frame. I'm just kind of eyeballing it, but I think that should probably be fine there. Let's see if I can just push it on there. There we go. Okay, so it is on. I'll let that cool down a little bit, and I'm going to come back and glue that tire on there. Okay, so I went ahead and glued that tire onto the hub, and everything looks good. Like I said, the colors are slightly off, but I think it'll be fine. And toy works. Everything looks good. Again, this is what CAD That Works is all about. Utilizing CAD to develop functional parts and actually making them and making sure they work. So thanks for watching, and if you like this kind of stuff, go ahead and hit like and subscribe, and put in the comments if you want to see any kind of different kind of projects.